Hi everyone, in your planners, we can be writing down day 5, which will be on page 47 in the packet. We're going to look at normal distributions today. Some additional things that you've got going. You've got your test 2 corrections you can be working on Delta Math. And you've also got your next problem set that you can be working on as well. So we're going to pause the video for 1 minute and have you answer your warm-up question. This should be the end of the warm-up for this 2-week cycle. So after doing this warm-up, we'll have the sub collect all of your warm-up sheets from you. So we'll pause the video for 1 minute now for you to do the warm-up. So our options for measures of center are mean and median. And our spread options, we have interquartile range and standard deviation. So if there is an outlier, we should be using the median for our measure of center, and for our measure of spread, we should use our interquartile range. And when we do that, that's Q3 minus Q1. If there was not outliers, we would use the mean and the standard deviation. So if you could have your name on top of your warm-up and pass those forward, the sub will collect those warm-ups and put them in the green folder for me to get on Monday. Going to the homework. So Jordan had a 53 on his math test. The class average, or in other words, the mean was 57. The standard deviation was 2. How many standard deviations below the mean was Jordan? Well, 57, if you subtract 2 once, that equals 55. If you subtract 2 again, that equals 53. So because we had to subtract 2 twice, that was 2 standard deviations below the mean. In science class, he scored a 114. The class average was 126. How many below the mean was he if he was 114? Well, subtract 6 once, you get 120. Subtract 6 again, you get 114. So he was 2 standard deviations below. So in comparison, how did he score in relation to his peers? Well, he actually did the same on both, because he was the same number of standard deviations below. And that's really the main point of standard deviations. It allows you to compare unlike things. We can see, based on standard deviations, how far you are from the mean, and 2 things that might not even have the same scoring system could then be compared. Our next one on the homework, the more compact, the smaller the standard deviation. So these ones are the compact ones, so they should have the standard deviation of 5. These ones are more spread out, so they should have the standard deviation of 10. Your mean is your balance point of the data. So your options were 30 and 50 for the mean for each of them. So I'm just marking where the 30 and the 50 are. So this far right one, this was definitely a 30. This second from the right was definitely a 50. This first one looks like it was a 30, and the second one, the best choice would be a 50. So the 30 with a standard deviation of 10, that was choice C for the first one. The 50 with a standard deviation of 10, that was choice B. The 50 with a standard deviation of 5, that was choice A. And a 30 with a standard deviation of 5, that was choice D. Next, put this in a list and spreadsheet page. Do your 1 variable stats. You've got your mean, 26.04. Standard deviation was like 1.50 and change. You had to tally up or count up how many there were of each in our list. There was 25 total if you added that up. So now we want to do how many are within one standard deviation of the mean. So start with your mean and add your standard deviation. Do your mean, subtract your standard deviation. So we have for our values that we should go from 24.54 to 27.54. So that's marked off in this gap of 3 of them here. So if we add those up, that's 17 scores all together. So we're going to be on packet page 38. And what we're going to do is we're going to look at a whole bunch of examples versus non-examples to kind of get an idea of what a normal distribution should look like. So the one on the left on the top is what would be considered an approximately normal distribution. The one on the right is not. Notice the one on the right is a bit of a left skew. It has a little bit of tail to the left. Our next one, the one on the left, is a normal distribution. The one on the right is not. Now, it might be tough to see in your packet, but hopefully you can see a little bit on the screen. The one on the left, notice the mean, median, and mode are at the same spot. While the one on the right, the mean is that little triangle, the median is the blue, and the mode is the red. So if the mean, median, and mode are not at the same spot, then that's not a normal distribution. In 3, this is a normal distribution. Notice it's got a nice bell-shaped curve. On the right is an example of one that's not. That's again got a tail to the left. That's left skewed. Here's another example of a normal distribution. The one on the right is not. Notice that one on the right has multiple mounds. The one on the left has only one mound. If we go over to page 39, normal distribution on the left, nice symmetrical. Over on the right, again, multiple mounds, not a normal distribution. Over to 6, left would be in a normal distribution, right is not because it's got a tail to the right. In 7, here's your normal distribution. We'll talk about these percentages here, the 68, the 95, the 99.7. We'll see those in a little bit. On the right, you've got multiple mounds. That's a problem. That's why one reason it's not. And notice the mean, the median, and the mode are in different locations. So based on those examples, some things that we should know from normal distributions, and this is number 9 where we're filling this in. We had that the mean, the median, and the mode were all equal. It was symmetric. So there's no tails going on. There was one mound. And that 68, 95, 99%, we're going to talk about what that means in a second here. So moving on to 10, we've got 3 examples of normal distributions here. And, or sorry, they're not necessarily normal, but just looking and highlighting how the standard deviation makes things look different. All 3 of these have the same mean. So notice the mound is at 3 for all of them. But there's 3 different standard deviation numbers. Like we talked about last class, the bigger the standard deviation number, the more spread out. So that standard deviation of 1, that's our biggest standard deviation number. That data is the most spread out. The 0.25 here, that's the smallest of the standard deviation numbers. Notice our data is the most compact. If we go over to 11, now compare that to ones where the standard deviation is the same for all of them. So they all have the same spread, but the location of the mean is different. The top left has a mean at 1, the second one mean at 2, the third one a mean at 3. So the same spread, but different locations of the mound because the mean is different. So a normal distribution, again, mean, median, and mode should be about equal. We should have one mound, it should be nice, symmetric. And we've got two scenarios here: average income of a household and weight of babies born in 1 year in the US. And we want to know which of these is better modeled by a normal distribution. Well, if you think about income, the majority of people are on the left end, but then you've got some hugely wealthy people. So our income, so this one's our income, would have a big tail to the right, because the richest people, billionaires, are making so much more than people that are making, say, 60,000, 70,000, 100,000. That's so much less than the billions, the millions, that you're going to have a big tail off to the right. But our rate of babies born, if you look at all the babies in the US, it should be fairly symmetric. It should have one mound. Yes, you have some, say, premature babies that are quite light. You have a few on the high end that are quite heavy. But in general, it should be a nice, symmetric, smooth mound. So that should be a pretty good representation of a normal distribution. So that one is for the babies. So moving on to 12. So a normal distribution depends on the mean and the standard deviation. Well, the location of the mound will change. So the location of the mound will change and how spread out it is, but it still has the same nice shape. The mean, median, mode are always equal for that. See bimodal. Bimodal would mean there's two mounds. If there's two mounds, then it's not a normal distribution, so that would be false. And this last one, 50% within one standard deviation, this is going to be false, and we're going to see on the next slide why that is false. So this slide here, star it. This is an important one. It'll come up several times on our unit test. If you're within one standard deviation of the mean, and it's a normal distribution, we expect 68% of the data to be within there. 95%, so if you're two standard deviations, and 99.7% if you're three. So if this is a normal distribution here, and this -1 to 1 is representing one standard deviation, we expect 68% of the data to fall within that one standard deviation. Now that's only if it's a normal distribution. If it's got skew to it, then we can't assume that to be true. If you're two standard deviations away, and that means if you go two in each direction from the mean, we would expect there to be 95% of the data. And then if you're three in each direction, that would be 99.7% of the data. So one of the things I mentioned yesterday was that data values that are beyond two standard deviations are unusual. If you're within two standard deviations, those are usual data values. Well, if you're outside of two standard deviations, there's only 5% left of data values out there. So that's why we would consider that unusual. So here's an example with women's heights. So this is really our mean here. So they're saying our mean is 64.5 inches and our standard deviation is 2.5. So that means two standard deviations is 5. So if you do your 64.5 and you add 2.5 twice, that would give us 69.5 inches. And if you do your 64.5 and subtract 2.5 twice, that would give us 59.5 inches. So assuming a normal distribution for women's heights, because we went two standard deviations in each direction, we would expect that 59.5 inches to 69.5 inches would represent about 95% of women. And that 95% is coming from the fact that it is two standard deviations and we're assuming a normal distribution. If we went out three, we would expect 99.7%. Now, what are the applications of this? Maybe you are making a product for women and you want it to be able to be used by women of all different heights, and you want to make sure that 95% of women can use your product. Well, this would give you an idea of the different heights that you should make sure your product can be used by. So again, some characteristics of a normal distribution. It's symmetric with the mean. It's bell-shaped. So bell shape kind of looks like that. Over on that side, I should make it a little flatter. So there's our mean. And I'm going to put a +1, a +2, and a +3 here, a -1, a -2, and a -3 here to represent our standard deviations above and below. If you go 1 standard deviation in each direction, we expect 68% of the data to fall within there if we're dealing with a normal distribution. If you go 2 in each direction, we would expect 95% of the data. And if you go 3 standard deviations in each direction, we would expect there to be 99.7% of the data. So I know there is a question on your test. It's a multiple choice. It says, how many standard deviations would you have to go out in order to include 68% of the data or something like that? And you would select the choice that said you'd have to go out 1 standard deviation. All right, so problem 1 here, we've got 15 players on the Arlington boys varsity basketball team. These are their heights in inches. We want to find the mean and the standard deviation. We're going to use the population standard deviation because it's implied that it's all the boys on the team. So we're going to need our x with the bar and our OX. And notice they want us to round those to the nearest tenth. So we are going to pause the video and we're going to give you maybe 4 minutes to do that. See if you can type these all in a list and spreadsheet, all in one column. Remember, when we use a list and spreadsheet, it's helpful to open a new document first. So go home, 1, don't save any changes, and open a brand new document. That way you can use any heading that you want. So we'll pause now for 4 minutes. Remember, you're rounding those each to the nearest tenth. All right, we should have gotten 72.5 inches for our mean and 3.8 inches for our population standard deviation. If you didn't get that, double check, make sure you type them all in correctly. So part B, we want to find what proportion is within 1 standard deviation of the mean. So we are going to start with our mean. We're going to have to subtract 1 standard deviation and see what we get. Start with our mean and add 1 standard deviation and see what we get. When we subtract it, we're going to get 68.7. And when we add it, we're going to get 76.3. So 68.7 would be in between here. 76.3 would be in between there. So if we count up how many there are in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of the 15. We're going to want to be able to compare that to our percentages. So we'll want to get the decimal. If we do 9 divided by 15, we get 0.6. So in other words, in this data sample, there's about 60% of the data within 1 standard deviation. So keep in mind how that compares to the normal distribution that we just talked about. And we'll get back to that in a second. Now we're going to do it for 2 standard deviations. So we're going to take the 72.5 and we'll subtract 3.8 twice. When we subtract it twice, we'll get 64.9. Then we'll take the standard deviation and we'll add it twice. And we'll get 80.1. So we want to go 64.9 to 80.1. Well, 80.1 is above all of them. 64.9 is below all of them. So all 15 fall within there. So that gives us 1. So we want to know if this data is normal or not. Well, we're never going to get a data set that's perfectly normal. So we always want to think about, is it approximately normal? Our targets, if it was normal, would be 68% and then 95% for 2 standard deviations. If you're within a couple percent of those in either direction, we would usually say that it is approximately normal. But 60%, that's 8% away. So 100%, that's 5% away. So we would probably want to say no. 1, I'm going to abbreviate standard deviation with SD. 1 standard deviation is not 68%. 2 standard deviations is not 95%. And again, we usually talk approximately normal, and it's approximately normal if we're nearby those values. All right, here's our next one. We've got biologists are looking at weights of red king crabs. They sample 16 crabs and compile their weights. So because it is a sample, we would want to use our SX. So we're going to find our mean and our standard deviation, and we're going to round them to the nearest tenth. It is okay that the data is not in order. Okay, you can still just put it in your list and the calculator will take care of it. So we're going to need our X, and we're going to, with the bar, and our SX. So again, we're going to pause for 4 minutes for you to put those in and do your 1 variable stats. A reminder again, open a brand new document, go home and then 1, then a list and spreadsheet so that you can reuse any headings that you want. So we'll pause now for 4 minutes to let you to do that. All right, our mean we should have gotten was 12.6 pounds. Our sample standard deviation was 1.5 pounds. So we're only going to do part B here. So we want to know, what would that tell us about the population, assuming it's modeling to see if it's modeling a normal distribution. So let's check our 1 standard deviation. If it represents a normal distribution, 1 standard deviation should be about 68% of the data. So let's start with our 12.6 and we'll subtract 1.5. Then we'll do 12.6 and we'll add 1.5. Well, when we add them, when we subtract them, we get 11.1. When we add them, we get 14.1. So we need all the ones that go from 11.1 to 14.1. So that leaves out 5 of them. So that means the underlined ones are 11 out of 15. If we divide that and look at it as a decimal, it's approximately 0.69. So we want to know if this would be well modeled with a normal distribution. So 0.69 is pretty close to that 0.68. So we would say yes, since about 68%. And we're going to skip C and D. And if we go over to the last slide for this one, remember a normal distribution is bell-shaped. We've got 68% for 1 standard deviation, 95% for 2, 99.7 for 3. If you got any skew, it's not a normal distribution. And then the last thing I just want to mention, say that your standard deviation was 7. And then let's say that a data value of 28 was 1 standard deviation above the mean. And we want to know, what is the mean? Well, let's say our mean is here right in the middle. That's 1 standard deviation above, 2 above, 3 above. 1 below, 2 below, 3 below. Well, the one that we know is 1 above is 28. Well, each time we jump from one to the next, we should be going up by a standard deviation. So it should be going up by 7 each time. So from the mean to that 28, we should be going up by 7, meaning the mean should be 21. So if you know your standard deviation, you can find any of the other spots as long as they give you one of them. If they give you the mean or any other spots either above or below it, you can find any of the others by just jumping by your standard deviation. So you've got the day 5 homework. If there's any time left in the period, you can be working on that now. Have a great rest of your day.